Okay, so let's begin the first lecture of pre-calc algebra. So most of this stuff is going to feel familiar. You've studied a lot of this in college algebra, but in pre-calc algebra, we're gonna do a more in-depth study of it, and we're gonna add some new stuff. So we'll start our study with functions, and you should be pretty familiar with functions, like what is a function and how we can visualize functions and how to use them in applied problems. Because in nearly every physical phenomena out there, we observe that quantities depend on other quantities. So for example, you can see that the cost of tuition depends on the number of credits you take, or the area of a circle depends on its radius, and so on. So we use the term function to describe this dependency of one quantity on another. If you recall, a function is just a rule. It just tells you what to do with the input to get a certain output. In general, we use letters such as F, G, and H to represent function. So for example, if I say that the function f represents a rule as follows, f is the rule that doubles the input and then adds 1. So I can call my input, let's call our input x. Then f of x, basically this is going to tell us the rule. F of x is equal to, what do? You take your input x, you double it, so I'm going to have 2 times x, and then add on. So verbally, the function is just saying what it does. Take the input, double it, and then add 1. And then algebraically, you just give an equation for it. Then graphically, well, you just have to graph the function. So if you recall from college algebra, I'm just going to take my input x and my output f of x, and we usually call the output y. So f of x is denoted with y. So we take a few points and then we plot them and then we connect the dots, and that will be the graph of the function. So my function is 2 times x plus 1, so the input x can be anything because I can take any number x and multiply it by 2 and add 1. There's no restriction. So if I take that x is negative 3, for example, then y, f of negative 3 is going to be 2 times negative 3 plus 1, and this is negative 5. So now I'll plot the point negative 3, negative 5. So negative 3 for x, negative 5 for y is going to be this point right here. Now, if I take another point, 0, for example, f of 0 is going to give me 2 times 0 plus 1 is just 1. So at 0, the function is 1. So I can connect the dots right now. I don't need more points, but just for the sake of it, let's take x equals 1, and f of 1 will give me 2 times 1 plus 1, and that is 3. So at 1, the function is 3. So now I have enough points to connect the dots and get the graph of this function. And we know that this is a linear function with slope 1 and y-intercept 1. So this is the graph of f of x. So just to recap linear functions, in general, linear function is of the type mx plus b, where m is the slope and b is the y-intercept. And if you recall how to get the slope was the change in y, change in the output, to change in the y values over change in the x values, change in input. So if I have 2 points, x1, y1, and x2, y2, the slope is going to be the change in y, so y2 minus y1 over x2 minus x1. And then the b, the y-intercept, is actually the function evaluated at 0. So when x is 0, you want to find the y-intercept. Okay. So to give a formal definition of a function is a rule that assigns to each element in a set A. So each element in a set A is assigned exactly one element called f of x in a set B. And if you recall, the set of inputs, the set A, is going to be called the domain of the function, and it consists of all the valid inputs. And then the set of outputs, set B, is going to be called the range of the function, and it consists of all possible values of f of x, as x varies throughout the domain. So again, from college algebra, we have studied quadratic functions, polynomial functions, rational functions, square root functions, quite a few different types of functions. So for example, if I let f of x equals x squared plus 2, what would be the domain of this? And I know that this is a quadratic function, right? So it's going to be a parabola up. What do I get for the domain? Well, you look at x. Can x be anything? Can I take any number and square it and then add 2 to it? Sure. I can take 0 and square it and add 2 to it. I can take -1,000,000 and square it and add 2 to it. So for this quadratic function, the domain is all real numbers. So this is how we write all real numbers. From -infinity to infinity. The entire number line. All right, another example. Let's let g of x equals square root of x minus 4. All right, to get the domain of this, we have to keep in mind that in order to get a real number out, I have to have that the quantity underneath the square root, in my case, the quantity underneath the square root is x minus 4, it has to be positive, because square root of a negative number is not going to give you a real number out. It's going to give you a complex number. If you remember from college algebra, square root of -1 was a complex number called I. But that was not a real number. So in order to get a real number out, the quantity underneath the square root must be positive or 0. So that means that x minus 4 has to be greater than or equal to 0. And then we add 4 to both sides, and we get that x is greater than or equal to 4. So this will be the domain in inequality notation, but we want the domain in interval notation. So how do I get that in interval notation? Well, you can think of, let's draw the number line. So the number line is all the real numbers from -infinity to infinity. And then I have 4, let's say 4 is here. Well, x greater than or equal to 4, it means everything after 4, including 4. So how do we know the fact that it includes 4? We put a bracket. So this is going to give us the domain in interval notation, which is going to be 4 to infinity. So domain 4 to infinity in interval notation. All right, let's look at another function. Let's call this one h of x, and it's x minus 1 over x plus 3. This is an example of a rational function because we have a ratio, and we know that we can't divide by 0. Okay, so this means that this whole denominator cannot be equal to 0. So from that condition, we get that x plus 3 cannot be equal to 0. If I subtract 3 from both sides, I get that x cannot be equal to -3. Okay, so the domain will be x cannot be equal to -3, but how do I write that down in interval notation? Again, I draw my number line, -infinity to infinity, and then -3, let's say -3 is right here. So my domain for this function h of x is everything but -3. So I'm going to put an x at -3. So nothing, everything before -3 and everything after -3. So in interval notation, well, this kind of already tells us. So it's everything before -3. So -infinity to -3, but not including -3. So I'm going to put a parentheses instead of bracket. And then we use union. And everything after -3, but not -3, again, bracket -3 to infinity, parentheses -3 to infinity. So this will be the domain for this h of x in interval notation. Okay, one more example. Let's see if we have f of x equals log of x minus 2. Again, the logarithm function, we know that what we call the argument right here. So whatever you're taking the log of has to be a positive quantity. So I have to think that x minus 2 is greater than 0. It cannot be equal to 0. On a side note, if you remember from college algebra, log, if there is no number right here, it means base 10. And log of, I can't take log of 0 because there's no power. 10 to what power gives me 0? There's no power I can raise 10 to get 0. So that's why this, whatever I'm taking the log of, cannot be 0 and cannot be negative. So it has to be strictly greater than 0. And this will give us, if I add 2 to both sides, this is going to give me that x is greater than 2. And if I draw my number line again, if 2 is here, x is greater than 2 means everything after 2 and not including 2, so parentheses. So the domain for this other f of x domain is going to be 2 to infinity. All right, another type of functions that you haven't maybe not discussed in college algebra is what we call a piecewise defined function. And a piecewise defined function happens when you have different rules for different pieces of the domain. So for example, if a cell phone company charges $40 a month if you use less than 500 minutes, but then if you go over the 500 minutes, you get charged an additional quarter per minute. So there are two rules, okay? So this function, this situation is going to be described by a piecewise defined function. So if let's find a formula for the cost of this phone plan, and we call this one C of x from the cost. So C of x is going to have two pieces. So it's going to be different if x, which is the number of minutes used, if x is less than or equal to 500, okay, it's going to be a rule. And if x is greater than 500, if you consume more than 500 minutes, it's going to have a different rule. So we're going to put this curly braces and we're going to say, what is the rule? If x is less than or equal to 500, what are you going to get charged? Well, it says $40 a month, a flat fee of 40, so just 40. But then if you go over 500, you're going to be charged a quarter for each additional minute. So you're still going to get charged the $40, and then plus a quarter, plus 0.25 for a quarter, for each additional minute. So think about it. If I consume 502 minutes, I'm only going to get charged a quarter for those extra 2 minutes. So I cannot put just x in here because then it will charge me 25 cents for all the minutes I use. So it has to be x minus 500. Sorry. Because if, for example, if I consume 502 minutes, then it's going to be 502 minus 500, which is 2. So it's going to charge me 25 cents for those extra 2 minutes. So this is an example of a piecewise defined function. It has two rules. So evaluate C of 450. Well, 450 follows under this rule. 450 is less than 500. So what is the rule? The function is, well, just $40. What does it mean? It means that it's going to cost you just $40 if you consume 450 minutes. What about C of 550? So the cost of consuming 550 minutes. Well, 550 minutes is greater than 500. So then the rule is going to be given by the second piece. So the cost for 550 minutes is going to be 40 plus 0.25 times x minus 500, but our x is 550. So it'll be 550 minus 500. So you'll notice in this class, we're not going to use calculators. So we're going to practice doing everything by hand. So 40 plus, I like to write decimals as fractions. So 0.25 is the same as 25 over 100. And then 550 minus 500 is 50. And then I can reduce this. 50 goes into 100 twice. So then this is going to give me 40 plus 25 divided by 2, which is 40 plus 12.5. So the cost is just going to be $52.5. So if you consume 550 minutes, the plan is going to cost you $52.5. All right. Evaluating a function and the difference quotient. So we know that evaluating a function at a certain value just means plugging that value instead of x. So for example, if I have this function 2x squared plus 3x plus 1, f of 2 is just going to be, instead of x, I'm going to put 2. And if I calculate this, I get 2 times 4 plus 6 plus 1. So it's going to be 15. Now I can also evaluate a function at f of 2 plus h. And h is just, you can think of h as just a small quantity. So f of 2 plus h is going to be, again, instead of x, my input now is this whole thing, 2 plus h. So it's going to be 2 times, instead of x2 plus h squared, plus 3 times, instead of x, I'm going to have 2 plus h, and then plus 1. So then if I calculate this, 2 plus h squared just means 2 plus h times 2 plus h, plus I'll have 6 plus 3h plus 1, and then this is going to give me 2, and if I FOIL this, I'll get 4 plus 2h plus another 2h, so plus 4h plus h squared, and then plus 6 plus 1 is 7 plus 3h. And then if I calculate this, I have 2 times h squared, this gives me 2h squared, and then I have 2 times 4h, I have 8h plus another 3h from here, so plus 11h, and then 2 times 4, 8, and then 8 plus 7, 15. Okay, so this is the function evaluated at 2 plus h. Now, find the average rate of change between 2 points. So the average rate of change of a function between two x values is just going to be the slope of the line that goes through those 2 points. So if you have 2 points x1 and x2, the slope is going to be just the slope going through x1 of f of x1 and x2 and f of x2. So in our case, x1 is 2 and x2 is 2 plus h. So if I want to find the average rate of change between these 2 points, so the average rate of change is just going to be the right here. It's going to be the slope, so it's going to be y2 minus y1 over x2 minus x1. But y2 is f of x2, so it's going to be f of x2 minus y1, which is f of x1, over x2 minus x1. But what is my x2? Well, my x2 is 2 plus h. So this is going to be f of 2 plus h minus f of x1 is just 2 over x2, which is 2 plus h, minus x1, which is 2. So this is the average rate of change between those 2 points. And we already calculated what is f of 2 plus h, is this whole thing. So f of 2 plus h is 2h squared plus 11h plus 15 minus f of 2. Well, f of 2 was 15 over 2 minus 2 goes away, and over h. And then the plus 15, negative 15 goes away. And then I can factor out an h between these two. So if I factor out an h, I'll have left 2h plus 11 over h. So the average rate of change between those 2 points, it gave us that was 2h plus 11. Now, why is this important? This quantity, when I let my 2 be any value a, so not just 2, if I wanted to do f of 3 or f of 4 or f of 5, that's going to be called the difference quotient, and is going to play an important role when you do calculus, because basically this is just a preview. If I let h go to 0, this difference quotient is going to be what we call the derivative at 2. So don't worry about that. That's just, I'm telling you that it's important to know how to calculate this average rate of change, this specific one in this form, because it's going to help you calculate derivatives in calculus. So in general, to find f of a, I would just have 2 times a squared plus 3a plus 1, and then f of a plus h is going to be 2 times a plus h squared plus 3 times a plus h plus 1. And then to find the average rate of change between x1 and x2, where x1 is a, any number a, and x2 is that number plus a small quantity h. We would just say that the average rate of change is going to be, again, f of x2 minus f of x1 over x2 minus x1. And then f of x2 is basically f of a plus h minus f of x1 is just f of a over x2, which is a plus h, minus x1, which is a. So then you cancel the a's, and the result for the average rate of change between those 2 points is this. And this is called the difference quotient. And like I said, this is going to help you calculate the derivative at a certain point, a, at a certain x, which is a in this case, for that function f. All right, so this is the only 2 new things in this lecture was the piecewise defined function and this difference quotient. So the difference quotient is just evaluating the function at some certain values and calculating the average rate of change between those 2 points.